So we're going to continue our work today with the Pythagorean theorem. And actually right above on these notes where it says the Pythagorean theorem, let's write again, a squared plus b squared equals c squared. This is essential to what we're doing today, and you're going to keep seeing this pop up in this year, future years, so you got to remember that one. So it says many real-world problems can be modeled and solved using the Pythagorean theorem. When solving these problems, it is always helpful to draw a picture. For these ones in particular, and I would say in anything you do with me, it's not helpful, it is necessary. You need to draw a picture in order to solve these problems. So let's take a look at a couple of different kinds. I'll try to keep this video kind of short like the last one. So it says a flat screen TV in the shape of a rectangle has a width of 36 inches and a height of 20 inches. Find the length of the diagonal. So you kind of just have to visualize each of these situations that they're giving you. So that's my TV. It's kind of lopsided, but whatever. And they said that the width is 36 inches. So if I'm talking about a TV, width is like that. So my 36 inches is going to be right there. And the height, so how high the TV is 20. And diagonal, and you can draw this a couple different ways, is right there. Because that's what they're actually asking me to find. So hopefully you can recognize right there is the right triangle that they're having me work with. And I don't know what the diagonal is, so I'm going to call it x. So again, let's start with figuring out what C is. C is whatever's across from the right angle. So in this case, it's x. I'll call 20a, I'll call 36b. So if I'm starting with a squared plus b squared equals c squared, let's plug some stuff in. And now this becomes exactly like a problem that we did the other day. The only thing that changed was we had to actually set up the picture to make it happen. So we'll do this math out. I got 400 plus 1,296 equals x squared. I'll actually add that stuff up. And then I'll take the square root of x, of x squared and of 1,696. So when I do that, x equals 41.2 inches. And again, you're usually rounding to the nearest tenth, so my actual answer there is 41.2. Okay, let's take a look at another one, because they get a little bit harder to visualize, but still not too bad. So it says a 20-foot piece of wire is attached to the top of a flagpole to a stake in the ground 8 feet from the base of the pole. So let's draw the pole. The pole's right there. There's my little flag at the top. And I got a stake on the ground somewhere over here. And here's my piece of wire. So hopefully you're starting to see my triangle is right there. There's my right angle. We said that this was my wire. They told me that was 20 feet. And if this is my stake in the ground from the base of the pole is right there. And they told me that was 8. They want me to find how tall that flagpole actually is. So how tall the flagpole is would happen right here. I don't know it, so that's going to be my x. So let's do the same thing that we've been doing. Find what C is, cross from the right angle. So that's C. We'll call 8a, and we'll call xb. So a squared plus b squared equals c squared. And I want you to be writing this formula over and over and over again when you start these problems so that you can actually see where stuff's going. So I'll put my 8 in for A, I'll put my x in for B, and I'll put my 20 in for C. So that's going to give me 64 plus x squared equals 400. And now I got a little work to do because my x squared isn't by itself. So I got to subtract 64 from both sides. Let me move my work up here. So that's going to leave me with x squared equals 336 and now I'll take the square root. And again, I'm going to have to round this one to the tenths place. When I do that, it's going to give me 18.3 feet. That's how tall my flagpole is. Okay, now let's do one more. I was going to do number 3, but I'm going to skip that one for now and let you try it on your own. Let's go over to the second page, and I want to look at number 8, because these are the ones that kind of get people. So it says, on a map, Norristown is 18 miles south of Lincoln, and Lincoln is 29 miles west of Allenport. Find the distance from Norris to Allenport. So this one's a little tricky because you kind of have to know on a map what's north, what's south, what's east, what's west. So over in the right-hand margin over here, I'm going to draw that. So up top, we got north, and the bottom we have south. This left piece is west, and the right piece is east. So if they're telling me Norristown is 18 miles south of Lincoln, so let's start at Lincoln. Lincoln's right here. If I go 18 miles south, so if I go down like my compass shows me, I'm going to get to Norristown. So they told me that's 18. They also said that Lincoln is 29 miles west of Allenport. So if the way I'm going to draw my picture, let me actually move this. Oops. So I had to go, starting at Allenport, I had to go 29 miles west in the west direction to get to Lincoln. So my picture looks like that. And they want me to find the actual distance from Norristown to Allenport. So hopefully you're seeing, again, that this is my triangle that I'm working with. And this is X. That's what I'm trying to find. Only side of the triangle I don't know. Once I've got that, let's figure out what C is. Crossing the right angle, so it's going to be X in this case. We'll call it 18A. We'll call it 29B. So I'll say, okay, A squared plus B squared equals C squared. A is 18. B is 29. And C is X. I'll throw that math together over here. This is going to be 324 plus 841 equals X squared. Which if I simplify that down, I'll get a 65 equals X squared. Take square root. And X is going to be 34.1. So my solution is 34.1 miles. So I want you to try the rest of these. Remember all of them. You got to make a picture and kind of visualize exactly what's going on, and then we'll come back together.